Okay, we'll come to the second part. Now, in this part, we try to describe the direction. And as we said, the direction depends on the what kind of charge we have. Are the two charges similar or opposite? Now, if we have similar, as we said, like we will have a repulsive force. If they are opposite, we'll have an attractive force. Now, the question is, okay, so how can we describe this? It's very straightforward, very simple. If I have Q1 and I have Q2. Now, these two charges, the force that these two charges will feel from each other, it will be always parallel to the line that is connecting these 2 point charges. So if I'm looking for what is the net force acting on Q1 because of Q2, then we say, like in this case, the magnitude of that force, F21 equal K Q1 Q2 divided by R squared. That's the magnitude. In this case, we don't have to worry about this one. Now, what about the direction? Now, the direction, and if I want to define the direction, I need to know what kind of charge we have. Let's assume that we consider Q1 as positive and Q2 as negative charge. Now, in this case, what kind of interaction we have? It's an attractive force. So the force that Q1 will feel because of Q2, it will be what? An attractive force. That will be F21. So it will be attracted to Q2. And Q2 also will feel what? An attractive force, and that will be here what? F12. Now, these two forces, as we say, like in terms of magnitude, they are equal. In terms of direction, they are opposite. So how can we describe this? It will be here F1, 2, or let's say like F21 here. Well, by the way, we'll ignore that later on when we try to find or solve problems. We'll try to be a little bit smart when we try to describe the force. It will be K, Q1, Q2, R square, R hat. Now, what's R hat here? R hat will be like the vector that, or the unit vector that describe the direction or the line between these two. Now, as I said, like here, positive, let's say negative in this case, we will see like in this case, the force will be parallel to that direction. Now, as we know, like F12 in this direction, F21 will be in this direction. So we could have, and if I describe, for example, R hat to be this direction, which is the unit. So you know, like unit vector here, vector means what? It's a vector that has a magnitude of 1 unit. And based on that idea here, this vector here will be in which direction? Parallel to the line connecting these two. Now, all what I need to know, is it in which direction? We know, like when we have a line, it could go left or right, up or down, or doesn't matter. So we can identify the direction by identifying the type of interaction. Is it positive? Sorry, is it attractive, or it's repulsive force? So after we identify the direction, then all what we need to know, define here is what is the magnitude. So the way we try to solve this type of problem here, we first sketch the 2 points based on the position described in the question. Then after that, we will be able to identify the direction of the force from the type of charge we have. So we will know, like in this case, the force acting on the Q1 because of Q2, it will be repulsive or attractive. After we identify this one, then we'll be able to know, like in which direction. Is it right, left, up, down? We will try to know this one. After we identify the direction, khalas, we are done. We don't need to worry about the positive, negative sign. We just need to worry about the magnitude. I'll try to explain that in a easier way when we start to solve some of these questions. But before we do this one, this is, by the way, that's a way to describe like the two forces here, that F12 and F21, they are equal in magnitude because this quantity will be the same, assuming that we have here the K, Q1, Q2 divided by R square, and the same magnitude here. The only difference will be what? The unit vector. And I don't want to go through the unit vectors to confuse you as a way to describe it as R2 minus R1. I will try to skip that part to make it easy for you to understand how we solve these questions. I will give you a very simple technique that we'll try to follow in order to solve any question. But before we do that, now all what we did so far, we just talked about 2-point charges. So we select Q1 and Q2. That's what we did so far. Q1 and Q2. Sorry, this is Q1. Q1. Now the question is, what about like if we have Q3 and Q4 and Q5? And I can keep going, by the way. Now, in this case, how can we solve this? And the question is, what kind of questions we expect to have? The question you expect to have, okay, if I have 5-point charges, and as I said, like Q1, Q2, Q3, the question is, what is the net force acting on Q1 because of the other 4 charges? Now, in order to know this, now I need to identify the sign of each one, because I'll not be able to know like what kind of force we have. Is it attractive or repulsive, unless like I know what kind of charge. So if let's assume that I arbitrarily choose like different type of charge. So let's assume that this is positive and this one is, let's say, positive, and this one is positive, and the other here, this one I can consider this one negative, and this one also negative. So in this case, again, keep in mind, I want to see like what is the force acting on the Q1, the net force, F1 net. How can we find this? How can we find this force? Now, all what we need to do here, I need to look at each pair separately. So I know like Q1 and Q2 will interact with each other. And based on that interaction, this F1 or Q1 will feel like a force from the charge, the second charge. And in this case, I have here what? F21. That's the force that Q1 feel because of the Q2. Now, that's the magnitude. Now, with this direction, in which direction this one? Since this one is positive and this one is negative, we expect that the force will be what? Attractive. So the direction of F21 actually will be in which direction? In this direction. Now, that's the first one. We know that there is also an interaction of Q1 with Q3. This one is positive, the other one is also positive. And now the question is, how can we describe this? The first thing we have to do, we draw a line that connect between these 2-point charges. And I know that the force between Q1 and Q3 will be parallel to that line. Now, in which direction parallel to that line? It depends on the charge. Now, since this is positive, this is positive, in which direction this force will be? A repulsive force. And that's what we call here what? F31. So that's the force that Q1 will feel because of the presence of Q3 at a distance here. Now, keep in mind that the distance, I can identify it, by the way, if you want. This will be like R12. This one I can describe it as R13. Now, we are not done yet. We still have like 2-point charges. Now I can choose a different color here to describe this one. Now, we know that there is also interaction between Q1 and Q4. What is the interaction we have here? I can describe it by first draw the line that connects between Q4 and Q1. And I know in this case, the force between Q1 and Q4 will be what? Parallel to that. And in this case, since this is positive and this is positive, we know that this force will be what? A repulsive force. So I expect the force F1 or F41 to be what? In this direction. Now we have, this is the third force, which is describing the force between 1 and 4. Now, are we done? Actually, not yet. Why? Because we still have another charge, and this charge will be what? The fifth charge. And again, with the same technique, the same step, all what I have to do here, I draw a line again that describe or that connect between the Q5 and Q1. By the way, this is Q5. I know like this handwriting is confusing, so I put here what? 5, just to make it clear. Now, since this is the line, the orange line here, this is the line connected with the Q1 and the Q5. Now, we know that what kind of force we have. Since Q1 is positive, Q5 is negative, so we expect to have what? An attractive force, and that's why this force will be what? Parallel to that line. So this will be what here? F51. Now, how many vectors do we have here? We have 1, which is F21, F31, F41, and F51. The summation, the vector summation of these 4 vectors will give me what we call F1 net. So in this case, I can say that F1 net will equal F21 plus F31 plus F41 plus F51. And keep in mind that this is what? Vector. Vector means what? I don't just add the magnitude of each one, algebra, no. We have to consider the vector summation here. What's the meaning of that? It means like I have to analyze each one of them as x component, y component. So F21 has F21 x I hat plus F21 y j hat plus F21 z k hat, if we have k hat anyway. Same thing for F31, and that's what will give me here F31 x I hat plus F31 y j hat plus F31 z k hat. Keep going with the same idea here, F41, F51, and I keep going here, F41 x I hat plus F41 y j hat plus F51 k hat. Same thing we do for F51 x I hat plus F51 y j hat plus F51 z k hat. Now, after we define this one, we add all of these together. Actually, let's try to delete this. Now, let's try to do it this way. Add these two together, and that will give me here what? F net x. So the x component of all of these forces, that will give me what? F net x. The same thing we do for what? For the y component. The summation of all of these, that should give me here what? F net y. And the same thing for the z component. And in this case, we can say that this will be at F net z hat, sorry, F net z hat. Now, these are the 3 type of components. So in this case, we can say that the net force F1 net, see here, I can write it this way, F1 net, which is a vector, can be described as F net x I hat plus F net y j hat plus F net z k hat. This is how we describe the net force, and this is very, very important. So if I give you a system of charge, in order to see like what is the net force acting on this one, I need to first look at each pair separately and identify what kind of force we have. Is it attractive or repulsive? And then we'll be able to identify the direction of the force. Now, after I identify the direction of each force, then I will treat each one as what? As a vector. Analyze it as X component, Y component, Z component, if we are dealing with 3-dimension. In most of our problem, actually, we will deal with what? 2-dimensional type of system, in such a way that the vector will always have like only 2 components, X and Y in general. And after we identify the X component, Y component, then we add the X component of all of the forces, and that will give me here what? F net X, and the Y component of all of the forces, and that will give me what? F net Y. And if I have the X component, net Y component, I can find the magnitude F net as a magnitude. Let me try this one in a better way. F net as a magnitude would equal F net X square plus F net Y square plus F net Z square. And that's, by the way, exactly the same thing we know. Like if I have a vector A, which has like AX I hat, AY J hat plus AZ K hat, I can find the magnitude of that, as you remember, as AX square plus AY square plus AZ square. This is something we actually should be familiar with. Now that's what we did in this case. Now all what we will do here, after we learn the concept, now we are ready to solve some examples and not some systems. And I will try to do a couple of examples before you start solving the worksheet that should be uploaded on time. If you have any questions, please, you can always ask me during the online session. Thank you very much. See you in the third part.